Do not cement your code. Imagine building a computer game where the player explores different types of dungeons. We have enchanted ones and ones with traps. If you set it up like this, you limited yourself to those types, and the new one will be much harder cookie to crack when adding it. And that is the moment when Abstract Factory truly shines. By the definition established by the Gang of Four, purpose of this pattern is to provide an interface for creating a whole family of related objects without providing their concrete classes. Each pattern has some intent, which we already explained in the previous video. Check it out. There. But how should we structure our class to achieve flexible environment in a growing system? First, we have an abstract factory, an interface that declares a series of methods for each needed product. In our example, this would be create doors or create room. Second is concrete factory, which is a specific implementation of the previously defined interface. For example, enchanted factory. This factory knows how to create each element from the family. Third is an abstract product. That is confusing to establish sometimes, yet this should be a general interface for a commonly present element, yet existing in specific configurations. Here, the examples could be door, room, and the last but not least, concrete product. This is where you implement the interface of an abstract product. But for specific ones like enchanted door, you can already see how this can be modeled into game environment by adding another and another room type. And then the client, us or other programmers, only use the interface provided by abstract classes and does not bother whether it's an enchanted room on one or another class of enemies, army, soldiers, or even a type of button on the web page. But this whole idea would be nothing without practical application. Our dungeon is still a rather abstract example. The common place to use this pattern is UI and system architecture, where we have different platforms and service providers. Yet you, as a developer, make them share one interface. Nowadays, this logic is often internalized inside the framework, and we are a client that uses abstract interfaces. So when you build an app with a framework that supports different platforms, it diagnoses which system we are on. The UI factory and window class, which you probably used now, is for example Linux UI factory and Linux window. And that is the beauty of this solution. This independence from platform dependencies is something that Martin Fowler anticipates in his POEAA, especially in the context of databases. Another point is something I already mentioned, that the whole implementation is rather uncommon nowadays, also when we use dependency injection in Java or C#. Instead of writing conditions for a specific factory by ourselves to be created, when we run the app, it gets done for us. Yet, like with everything, there are also drawbacks. Imagine a whole abstract factory for our dungeons created, and now you need traps or other object that can be another version of existing abstract products. Now, each change in the interface results in making existing implementations match the interface. To sum up, Use abstract factory when you need a bunch of related objects to be created accordingly, but don't overdo it. Abstract factory only makes sense for larger structures, not for two types of objects that share purpose. It is a factory, not a manufacturer. Also, it is a good practice to pair it with a singleton, about which we will talk soon, as you rarely need two instances of one factory. I hope that today's video cleared up the topic of the solution, and when you find yourself solving problems of creating related objects by their type, you will solve them with an abstract factor. If you ever needed to use this pattern, what was the situation like? I'm interested of circumstances, especially in times when this approach is often hidden in frameworks.